Alright, hello everyone. In this video, I'll be teaching you how to use Excel to perform some very simple and basic analysis on data. Alright, so I have a sample data here, data that I have gotten from soil tests where the liquid limits and the plastic limits were determined at different depths at 15 cm and at 50 cm at different points. So what kind of analysis can we perform on this data? And one thing we can do, we could create charts. All right, we can create charts. We can perform, we can do an analysis of variance to see how it varies from point to point. Now notice that there are 14 points here. So we can do an analysis of variance to see if the results vary from point to point. We can also perform a test to see if the result, for instance, varies from depth to depth. Okay, so looking at these two depths here, 15 cm and 50 cm, are these results statistically or significantly similar or different? A test can show that. So these are some tests that we can carry out on this data. So let's see how we can do this. Now, when you go to your data, tool here, you normally will see, okay, I don't even have it out. Okay, so I will need to, there should be a section here where we'll have my toolbox, my data analysis toolbox, but I don't have it. So this is what we'll do. We'll go to File first, we'll go to Options, and we'll go to Add-ins. And then come down here, make sure you have Excel add-ins checked, then click on Go. Then here I'm going to highlight these add-ins are available, and I'll just click on OK, and I'll watch it roll. Good. Now you can see this analysis toolpack have been added. Okay, so if you don't have this added already in yours, please follow the process I have just outlined and you get it up and running. So we're going to select data analysis. Now here you see a wide range of activities you can carry out using your data analysis toolpack. You have your ANOVA. ANOVA means analysis of variance, single factor. We have analysis of variance, two factor. You have your correlation, covariance, descriptive statistics, and many others. All of that you can select from here. Now, let me just quickly explain what analysis of variance single factor simply means. A single factor here means that you're considering, say, one direction. Here's what I mean. For instance, I want to determine, looking at this data we have here, if the data varies from point to point. That is, this is point 1, point 2, point 3, and to point 14. Do we have significant variation from point to point? Then I'll go for the single factor. Now, if I want to determine a variation from point to point and also from distance to distance, then you see there are two factors you're considering now. So I'll go for the analysis of variance 2 factor. Okay, so you need to know which to use depending on the kind of analysis you want to carry out. Okay, so let's try it out. Now let's look at analysis of variance single factor. Let's see how it works. I'm going to click on that. And it's asking me for my input range. Okay, so I'm going to select all of this. But before I do that, let me close the gap here. So it won't have a problem. Okay, that's fine. So that is that. I go back to my data analysis toolpack. I select analysis of variance single factor. Click on OK. Now, what's the input range? I'm going to select all of this as my input range. Now, remember, I've selected a single factor. In other words, my analysis to be performed, how do I want the analysis to be performed? Is it going to select data by rows or by columns? Now, if it selects the data by rows, it means I want to determine, if you notice, look at the rows here, you have points as the labels. Selecting data by rows here means I'm interested in seeing how the data varies from point to point. If I select by column, It means I'm interested to see how the data varies from depth to depth. Okay, so I'm just going to come here and click grouped by rows. And so I'm going to come here and click label in first column. Remember, when I was selecting, I selected everything here, including these labels. So labels in first column. And then I just click on OK. Okay, it says I have non-numeric data. Okay, sorry, I selected wrongly, so I'm going to go back. I shouldn't have put all of this, so I'm just going to select this instead. All right, I think we're good now. Click on OK. All right, so here it opens the results. It opens the results. Now this is the point of interest. Now what do you see here? Now you see your F critical value, and you see your F value, and then you see your P value. Now we must be able to interpret this, all right? These three values, we should be able to interpret this to give meaning to our results. Now here's what these results mean. When your F value is less than your F critical, it means that there is no significant difference in the results. So it's like this. When F is less than F critical, okay, no significant difference. Conversely, when F is greater than F critical, it means there is a significant difference in the results. Okay, so when F is greater than F critical, where did you go to? Okay, so when F is greater than F critical, it means there is significant difference in the results. But when F is less than F critical, it means there's no significant difference. So let's look at this. You can see here that your F critical is 1.96 and your F is what? 1.86. What does that show? That means there's no significant difference in the results. This means that the results you've gotten from the different points are statistically similar. That's what it means. They're statistically similar. So as you go from point to point, your results are statistically similar. So that means point 1 to point 14, they share similar traits. Okay? But then, when your F peradventure becomes greater than F critical, it means there is no difference. So each point are unique. Point 1 is unique compared to point 2 and other points. Alright, so for this example problem, there's no significant difference. And the same thing applies to your P value. Similarly, when P is greater than the alpha value is your 0.05, right? 0.05, but it's greater than that, then no significant difference. So you see, this works is similar to when F is less than F critical. All right, so they work together. So whenever F is less than F critical, P is always greater than alpha. Similarly too, when you have okay, similarly when you have F, when P is less than the alpha value, which is 0.05. Okay, so you have significant difference. All right, so as you can see here, the value of P is greater than 0.05, which is in connection with what we've said earlier on. F is less than critical, so there is no significant difference. So in your report, or when you're reporting this, you simply tell us that when you go from point to point, there's no difference in the soil samples you have collected significantly. Now, let's look at another one, the single factor, but this time around, we're going to look at the different depths. Now, bear in mind that these are two different results. This is a liquid limit and this is plastic limits, right? So we're going to do them individually. So let's look at single factor now. And this time around, I'm going to be selecting it this way. Okay, I'm going to be selecting it this way and I'm grouping it by column. Now I've ticked label in first row, which means that this is labeled here. So I'm going to click on OK. Now what do you have? What do you have? Now you can see clearly that F is greater than F critical. What does that tell you? It tells you that there is significant difference in the results. Therefore, as you go deeper in your sampling, these are 15 cm and these are 50 cm. Because you have gone deeper, the 50 cm result is significantly different from the 15 cm results. Let's try it for plastic limits. Let's see what we get. So I'm just going to select this guy as well. Label in first row, groups by columns. Okay, I click on OK. The same values. So you see your F value is greater than F critical, which shows that you have significant difference, and your P value is less than 0.05. So this is how you interpret this result. So if you see a table like this, it should be easy for you to interpret, looking at the F, the P value, and the F critical value. All right. Now let us try the two-way analysis of variance now. Let me show you how that works. I'm going to do a two-way analysis of variance that compares both different points and different depths at the same time. So I'm going to do this, and I'm going to select without replication, two-factor without replication. So I'm going to select the input range, which is this. I'm going to select labels. Alpha value is constant at 0.05. I'm going to click OK. All right. Now we can see here from this result. That because I have taken the two factors into consideration at the same time, this is what I have here. It shows that going by the rows, and the rows represent the different points, right? So going by the rows, our F value is greater than F critical, which means there's a difference. Going by the columns, which are the different depths, our F value is also greater than F critical, which also shows that it's a difference. So going by the two-factor analysis of variance, it shows clearly that from point to point and from depth to depth, there are statistically different or variation in the data we have gotten on the results we have analyzed. All right, so just merely looking at the F value, and notice also the P value, like I've explained. See, the P value here is way less than 0.05, same as this. All right, so this is how you carry out your analysis of variance on your data. So I'm pretty sure you can do this right now. All right, so what more can you do? And like I said, you can chart. You can chart this. For instance, you can decide to do a plot like this. Probably. You can decide to add any one of this. Okay, so we'll add the column charts, and this is what it comes out to be. So you notice here that you have the red one representing the liquid limit at 15 cm. The blue one representing liquid limit at 15 cm, and the red is liquid limit at 50 cm. So you can decide to add a chart title if you want, and then you can decide to add a scale here by the side. And of course, to do that, look at your chart elements, look at the axis title. So once I click this, you can add a title here. So I can call this application, and I come back here. I'll just title article, and then I call this percentages. First bracket. You could delete this if you don't want it. You could delete the background line if you don't want it. And so something like this. So these are results that you can copy into your Microsoft Word document and you can explain them. Alright, so these are some tests you can perform on your data. I hope this helps, and I hope you can carry out this kind of data analysis on your own. Thank you for watching.